Welcome to the video tutorial on how to enter data into the LCA to Go web tool for machine tools. Part 1. You can access the tool through the project website. Please register and create a user account before you use the tool. This graphic gives you an overview on the video tutorial. The rough assessment will give us a first impression of the environmental profile of the machine tool. Thereafter we can decide which data should be improved in the detailed assessment later. Rough assessment. In this case study, we investigate a grinding machine. We create a new product and select the industrial sector, machine tools. We indicate the main specifications of the machine tool and select the assessment method, rough assessment. Stage 1. Materials. In this stage, we add the type and amount of materials that is contained in the machine tool. We add all the main materials and supplier parts in the LCA to Go tool. For example, in this case study, the parts of the machine tool, such as the workpiece holder, the tool holder, and the machine foot contain approximately 13,000 kilograms iron. We select the type of material and enter the mass contained in the machine tool. If you make a mistake, you can change the quantity directly in the list, or delete the whole entry. Supplier parts are externally produced parts. Their usual supplier parts are already predefined in the tool. Stage 2. Manufacturing. Manufacturing includes the own manufacture of parts and the assembly of the machine tool until it is ready to leave the factory gate. The manufacture of supplier parts is included in the materials stage. In this stage, we add the energy used for manufacturing the product and the waste generated in the manufacturing process. In the rough assessment, it is sufficient to enter the overall energy consumption that is required in the production and the waste generated. The machine tool is produced in Germany. 25,000 kilowatt-hours are consumed in manufacturing for diverse metalworking processes and for assembly. In this example, there are 2,000 kilograms waste from manufacturing in the form of metal chippings. Stage 3. Distribution. We enter the distance between the manufacturing site and the customer who purchases the machine tool, and the kind and amount of packaging that is used in the distribution. The machine tool is delivered to Sweden by truck. We choose the option overland for delivery. The machine tool is packed into PE foil. We enter the approximate amount of material that is used. Stage 4. Use. In the use stage, we have to assume a realistic use scenario, and enter the energy and resources that the product needs for its operation. The LCA to Go tool differentiates between 3 operating states: processing, ready for operation, and standby. We enter the electrical power consumption for these 3 operating states. The exact modeling of the use stage is important for the robustness of the results, as previous investigations have shown that the major environmental impact of machine tools comes from the use stage. The manufacturer uses the machine tool 250 working days per year and produces on average 6 parts per hour. "12 hours per day the machine tool is processing, 4 hours per day it is ready for operation, 2 hours per day on standby, and 6 hours it is switched off." Stage 5. End of life. We assume a realistic end-of-life scenario. It is safe to assume for machine tools that the great majority of contained materials can easily be recycled. We select the option Recycling. Results in the data quality indicator. As you can see, we are missing the data quality indicators. To add the data quality, we click on to Data Quality. We enter the data quality indicator for each life cycle stage and define whether the data is robust, indicative, or illustrative. Use the descriptions to select the right data quality indicator for each life cycle stage. Based on the data we have entered, the results shows us the cumulative energy demand in the 5 life cycle stages. Results. Rough assessment. The previously entered DQIs now appear next to the results. On the results page, you can switch between numbers and percentages. You can expand the 5 life cycle stages to see the detailed breakdown. You can also export the results to Excel, and you can create a PDF file. In the analysis, we try to understand the results and draw conclusions for the further steps. Analysis. It can be clearly seen that the major environmental impact comes from the use stage. Typically, a machine tool is a use-intensive product. The data quality indicator identifies the robustness of the results. The life cycle stages with the greatest impact should be based on robust data. As we can see, we need better data for the use stage, which accounts for 94% of the cumulative energy demand. We have to be sure that we have the most robust data for the most important life cycle stages. In this case study, we have identified the environmental hotspot, the use stage, but the data is only indicative, so we will try to collect further data and improve the level of detail and robustness of the results. The next step is to create a new model for the detailed assessment. In this model we use more detailed data and focus on the stages with the biggest environmental impacts identified in the rough assessment to achieve a more detailed and robust environmental profile. The results will enable us to draw the right conclusions and identify the improvement potentials.